This is the last person between you and lunch, so please be nice. He's the honorary member of Hodl Gang. He's the boss of blockchain. Hey, welcome. Please be seated. Please give a warm round of applause for Andrey.
Hi. Hi, everyone. Can you hear me? Yeah, cool. Hi, I'm Andrey, and today I would like to give you a small introduction to the blockchain. Some of you probably heard about Bitcoins and other cryptocurrencies. And blockchain is just technology behind those cryptocurrencies. And because this is technology, we could use it in some other cases. Let's have a look. From the bird's eye view, blockchain is a ledger. It's a list or set of records or transactions which holds some data. It has some remarkable properties. One of them is that you cannot erase any record from the ledger. You could only append to it. And that's probably how ledger look like, or blockchain look like if we lived in the 19th century. But nowadays, our ledger looks like this. This is a distributed network of peers. There is no central authority, central body, or central server which can be turned off. All peers are independent. They make transactions between each other, signed transactions, of course. And then they broadcast all these transactions to other nodes. And every node has its own copy of the ledger. And this brings next interesting questions. How the nodes can agree what's the most correct ledger? How can they be ensure that all other nodes got exactly the same transaction in exactly the same order? So basically, this brings two problems: trust and ordering. Let's look at trust first. Nodes trust the ledger which has most computational power or effort put into it. It's quite complex subject. It might take some time to think through, but let's see. Let's see how can we work through it. So there are some nodes which validate or mine blocks of transactions. This is called proof of work. And what they precisely do, they just solve complex mathematical or computational problems. So here is an example. We have a block of transactions, and miner needs to find a special number, which is 42 in this case. It's called nonce in terms of Bitcoins. And when the cryptographic hash functions applied to this block together with this number, the resulting hash code should be starting with 30 zeros. This is not a trivial task because you cannot guess this number, this nonce. You have to go through all numbers, through all transactions until you get this. So this is computationally intensive. Its probability, if all inputs are random, the probability is about 1 per billion, and it takes around 10 minutes to calculate this. So, but it takes very easily to verify it as long as this number is found. And this, what other nodes can verify very easily and very fast. Now, let's go back to our example. Who are those miners? Actually, any node can become a miner. It does not matter. All nodes in the network can be the miners. So what do? They try to solve these computational problems. And the beauty of blockchain that they compete, the nodes, they compete each other in order to find this number. So in this case, Alice was faster than Dave, for example, and she got a small reward for spending her CPU, her electricity, and finding this number. This is how proof of work works. This is how nodes get trust about all transactions. It's not worth for for hackers nodes to do this. It's better to play by the rules. Now let's look at the ordering. We had already blocks. And now we chain them in such a way that every block has a hash of the previous block. So they form a chain. And if we tamper with any data in the previous block, it will change its hash code. So the next block will not be referenced anymore. So it becomes also harder for tamper with these blocks. So now you could see, maybe with some rough transformation, how we transformed the ledger to chain of blocks, or we could call it a blockchain. Everything we talked so far was a public or permissionless blockchain. It's open for read and write anyone. Anyone can get just a software key and start, doing business there. There is absolutely no trust between peers, so that's why we use these proof-of-work algorithms. There are proof-of-stake algorithms and some other consensus methods. Transactions are relatively slow. They can be minutes before one block is verified or mined. And think about it as an internet. So there are a lot of people, a lot of strangers. Some strange stuff can happen there. But there is another breed or type of blockchains which are called federated or permissioned. They have admins, and not totally, totally unmanned. There are some admins which give you rights, permissions. They see what you could do, what you cannot do. There is more trust between participants, and usually there are less participants. They have faster transactions, and analogy is internet. And this federated blockchains, they have more usages, for example, and they can be used in a supply chain. Let's look at an example. Yeah, you know this? So everyone in bol.com who submit an abstract for any conference will get a reward, nice Tony Chocolonely bar. On the back of this wrapper, you could see that it's fair trade and they don't use slave labor. But as a customer, how do I know? I couldn't track it down. There is some QR code and there is some number, but I could not get any sense. My phone simply does not work on it. If they use some blockchain, some federated blockchain, I don't want this farmer, to spend, hours for mining this block. So I could easily track which country this cacao beans comes and how they end up in the Tony Chocolonely factory. And that was it. Thank you very much for your attention.
That was wrong. There's another one who's in time. Questions. Anyone? Yes, I see a question over there. Would you do me the honors? Please watch out for the people who didn't mean it like that.
I haven't done this before. Sorry, guys.
Oh, nice arm.
Okay. In Bitcoin, you get a Bitcoin for mining a block, but there's a finite number of Bitcoins, right?
Yes, exactly.
So what happens when all the Bitcoins are distributed?
Great question. So the nodes who want their transactions to be validated, they will pay a fee. It's like nowadays when you want some transactions, you pay a little bit to the bank in order to make sure, So that's how they're going to work around it.
Then all the miners will get money instead of...
Exactly. They will still get money, or Bitcoins in this case, but not rewarded by the network, but given by the other nodes for computation, for validating their blocks.
Okay. Thank you.
Other questions from the room for now? Yep, I see a couple. That one's closer by.
Tear it apart.
Hi, Andrey.
Hey.
Do you see any use cases here inside the vault to do this kind of...
Supply chain, as I mentioned, for example, I don't know, this MacBook probably made in China, something like this. Some people, they really want to know which part of China it is. Maybe it's on the border with North Korea, and some people, they don't want, to have any relations with that area. Another thing is orders. Yeah, orders come from our warehouse via transporters, or maybe from our Plaza partners to their end customers. Sometimes our Plaza partners slow, transporters, PostNL goes on strike, and customers, they have no idea where their order is. They start calling to partner service, but partner service works till 5 or 6 o'clock, and if you after that, you're out of luck. If we can give a way to say, hey, your order is here, probably still at the post office, or maybe, we have a Plaza partner which forgets it. That might be one of the usages. But I'm looking forward to hear more usages from you next year on the Spaces Summit.
Nice comeback. I saw another question somewhere around here. I think Ivan was first. Oh, wow. Nice.
Nice throw.
Yeah, I would like to give you a bit of more chance to elaborate on the logistics, because for me, I also think that the logistics application is best for bol.com, something like VeChain, for example. But you can elaborate on it. So, for example, how do people know that it comes from China, right? There are projects, okay, this might not be a question, I'm probably just talking.
Maybe do a talk.
You want to come to the stage?
No, yeah, next year. So basically, for example, what VeChain does is they have chips, RFID chips, that are embedded in the products themselves. And basically, those chips are talking to the blockchain itself. And then if somebody tries to break the product, like if it's a wine glass, they already have an application for this you can check out yourself on the phone. If you try to break the wine glass, the chip breaks. And that automatically means it cannot be put anything else on the blockchain, and then it's basically tamper-proof completely from beginning to end. Of course, if those chips themselves are okay, and the balls are okay as well.
Okay, I'm not sure if that was a question, but
Not a question.
I don't know if there's
Yeah, thanks for the
organization
addition.
in the room. I think Ivan just gave an abstract for next year. It'd be nice. Awesome, Ivan. Another question here?
Yeah, I think it might be related to the answer Ivan already gave. But one of the things I've been struggling with when thinking about use cases is that one of the things that's a good thing about blockchain as a ledger, as for Bitcoin, that you can validate its correctness by the data itself, because you can just add up the numbers and see that no money is being created. And I see always examples of this, like in logistics domains and adding sort of steps of the supply chain process to a blockchain. But that starts with the trust that whatever I say I did, that I'm honest in that. So it's true that you cannot mutate it once it's there, but if I put in things that are not true, it's hard to validate that intrinsically. And I think that's a tough thing to solve. I don't know whether you have any ideas on it.
It's a tough thing to solve. There are always ways to tamper, even with blockchain, original ledger, which uses proof of algorithms. If you take over, let's say, 51% of the nodes, you could put a fake blocks there, even inside blockchain. So yeah, it's not a silver bullet. No.
I'm really impressed in how you did manage to turn that into a question.
I learned from
Nice.
right?
Very good. Okay, any other questions from the room for now? No? Oh, there's one more question here. Hey.
Yeah, so if you wanted to use this, for example, for the bol.com supply chain, would you have to set up your own network with your own coins and stuff like that, or could you just run it on one of the existing ones?
I would use definitely something off the shelf. There is many, for example, Hyperledger backed by Linux Foundation and IBM. So no, I would rather use something off the shelf.
Thanks.
Okay. One more question from me, if I can be so. Have you ever built something yourself with this already?
No, I just only play with it. I don't have any cryptocurrency, but yeah, everyone else around, hey, Bitcoin, hey, blockchain.
Maybe we should save this for lunch.
So no, I didn't.
Okay. Thank you.
Thank you.
Okay. Please be seated. I won't take long. We'll have lunch until 5 to 1, and then everyone will be back in this room for one talk. And then after the talk, we will split out over the other rooms again. And then for the speakers in the room at 12:30, there will be a speaker photo here in this room, so please be there. So this room, 12:30, if you're a speaker. And besides that, lunch.